Hey, this is Jamie Dawson Codes with Slice of Life Coding. And in this video, you'll probably notice that the microphone actually sounds a lot better than normal. That's because I ended up getting a new one. So videos from now on should sound a lot more clear. So very excited to use this new mic for this video that we're doing today, which is LeetCode question 242 valid anagram. So starting off with the actual description itself, given two strings s and t, return true if t is an anagram of s and false otherwise. So, in case you don't know what an anagram is a word or a phrase formed by rearranging letters of a different word or phrase using all the original letters exactly once. So, in this example, anagram, this returns true because there's there's three A's, there's one N, there's one G, and then there's one R, and no, you could rearrange this and it would match all the letters in this. But this here returns false because rat and car, there's no R in, well, sorry, there is an R in car, but there is no C in rat. So that would return false. So starting off, let's go ahead and talk about the two solutions that I have. So the first one's going to be a little not optimized, and the other one will be a bit more optimized, and we'll go with the second one. So the first one is to sort and compare. So this is actually pretty easy. What you're going to do is that you're going to take the string and you're going to use, you can use built-in JavaScript commands. So you use split, sort, join. So the split would turn uh, this S string anagram into an array where every single letter is its own spot. The sort would sort it from smallest to largest, and then you use join to basically return it back from an array to a full string. And so basically what you would do is that anagram and this word, whatever how you say that in the letter for the string t, both of these would be organized from this letter right here all the way up, and this letter all the way going up. And then step two is compare. So what you do is for S and T, you would have a pointer for each one, and then you'd say, is the zero spot the same as this? Yes, okay, let's move forward. And then you keep going to every single spot, comparing the same with this. And if you get to the very end, you can confirm that it's true. But if not, you would just return false. So the time complexity for that is going to be O of n log n, simply because of the sort command that you're using in here. The sort command that's built in the JavaScript, for example, it has a time complexity of O of n log n. So whenever you use that, that's like the worst case scenario of of your time complexity. But the space complexity is just going to be O of n because of the split. Now, you would probably be thinking, well, oh, am I not? Am I actually making space? And yes, you are. So what you're doing here, even if it's just for a little bit, you're taking the string and you're making the array the size of all of the letters that are inside of the string itself. That's what split does. So because you're using split, you are looking at a space complexity of O of n. Now, I think we can go ahead and find a much better time and space complexity than this. And to do that, we're going to do, let's go with solution number two, which is using a hash map. So what is a hash map? Well, the simplest way to describe a hash map is object that stores key value pairs. So one of the things that you could do is that you could take this string, for example, with that's just cat, and then you could turn it into a hash map, and then you basically turn it into this object where it would show how many times that letter appears in the string itself. For example, like cat only has one C, so C is one. It has one A, so just one, and one T, so it's just one. And if you were to like call on a hash and say, hey, give me the value of C, it would return you like just one. So now you have a basic idea of like what a hash map is. How would we actually use it? Well, first thing we would need to do is we need to create and store the hash map from S. So we're just using like the S string here. And what I want to do is that, I'm going to make this hash, and I'm going to count as I'm going through the string one at a time. I am counting how many times I find that letter. So I'll either A, um, discover that like this letter is not in the hash, and so like I will have to create it and then set it to 1. Or the other option is that like I already found it and I will increase that value by 1. So as I'm going through here, I'll see like, okay, found A 3 times. So set that to 3. There's only one N, only one G, only one R, and only one M in Anagram. So now what I'm doing, now that I've made the actual hash by like going one at a time and just incrementing every single key in here, what I want to do is I loop through the T string. And T is going to basically be used one letter at a time to decrease the values that are found in the hash. And from there, um, what I would basically do is I would say like, okay, I found N. I'm going to go to here, the N, I'm going to decrease it, and I would set it to 0. A, it would go here, so it would go from 3 to 2. G, go from 1 to 0, so on and so forth. And you're going to keep doing that until you get to the very end. If you get to the very end, then you can confirm that like yes, it is still true. It is true, so you can just return true. But if you're scrolling through here and you've either the letter does not exist, or you find that the letter that you're currently looking at is already set to 0, because maybe there was more than one of that letter and it decreased by 0, then you would also return false on both of those things. So false is I could not find a letter from T anywhere in here, or one of these letters is set to 0. So now that we know how the algorithm works, let's talk about the time and space complexity. So time complexity, technically, we are it's going to be n plus n, but with time complexity, you drop the constants, so that would actually just drop all the way to O of n. And n plus n basically refers to s and t, so s and t are basically like the same size, so just saying n plus n makes a lot of sense. And space complexity. So space complexity is going to represent with O of k, and k is going to represent one entry per unique character. So for every unique character, as the space complexity will be O of k. All right, so to start off with the code, the first thing I like to do is I just like to check if s and t is even the same size. Because the thing is, like, if they're not the same size, then that means like it's just impossible for it to be an anagram. So from there I can just return false if s length and t length are not the same. Next I need to go ahead and make the hash itself. So just basically make a little empty object. Now what I need to do is I need to fill the hash with all the letters that are inside of s. So I'm gonna have a for loop, so let I of s. Now I'm checking two things. If hash does not have I in it, so basically if that letter does not exist inside of the hash, then you do hash I equals 1. So you found one letter, you're creating it, and then you're setting it to 1. Else, which means like you already actually found the letter, you do hash I plus plus. And so that takes the letter that already exists, and you take whatever value it is and you increase it by 1. So by doing that, you have now gone through the entirety of S, and you have filled up the hash with all the letters that are inside of it and how many times they exist inside of it. So now we need to go ahead and loop through T to see if we can use T to compare all of the things inside of hash and then decrease those values one at a time or confirm whether or not they even exist in the hash itself. So do another for loop. So let I of T. Now we need to check if hash I does not exist, so that this letter exists, or if hash I is equal to 0. If either of those statements are true, then that means we are not looking at an anagram, so we have got to return false. Else, we just go ahead and take that hash and we decrease that value by 1. Once we're done with this loop and we've gone through everything and all these values have been dropped, uh, we can safely say that like all of the values, everything inside the hash is now all set to 0, so we can just return true. So let's test the code. I'm going to go ahead and submit it. And it passes. So that is the end of this video. Thank you so much for watching. And if you enjoyed this video or want me to tackle maybe some either easy or medium level LeetCode questions or have one you'd like to request, feel free to drop in the comment section. Other than that, I am Jamie Dawson Codes, and thank you so much for watching.